Good morning to you all, and welcome to our new edition of Weather Academy. Once again, for this school year 2021 here, and hopefully you're having a good time here. And we'll be doing it once again every Wednesday morning, and we are excited to be back once again. So today, again, I'm meteorologist Tom DeVecchio. I am your weather guy for this morning. And today we're going to be chatting about weather systems. We're talking about high and low pressure systems that affect our weather. So before we talk about the systems and get to some of the graphics, let's go quickly, first of all, with what is pressure? Because pressure systems and weather systems are high and low pressure. Well, air goes up about 400 miles high into the atmosphere. Now, the majority of the air is in the lowest 1 mile. Actually, most of the density, most of the air is packed here in the lowest 1 mile. And of course, because air does have weight, we may not think it does because we can move our hands through the air and we have no problems moving through. Like, what weight? Well, it does. In fact, when you look at my hand, on every square inch of my hand and your hand, you have almost 15 pounds of air pressing on every square inch of your body. Now you say, well, why don't I feel it? Because over time, your body actually pushes out with the same amount of pressure, and therefore you don't feel it. You know, we've developed that as humans over the past millennia, and therefore we don't feel the pressure. Now, what happens though if you dive into the bottom of a pool? If you go to the bottom of a pool, you feel the pressure, especially in your ears and your nose, which are much more sensitive to pressure changes. Because now, when you go to the bottom of the pool, you not only have the air pressing down on you, but you have the much more dense water, the liquid water pressing on you as well. So that increases the pressure. And then you start to feel it, and that's when your ears plug up, and so on and so forth. So air pressure is simply the pressure of the air pressing down on you. If there's a lot of pressure, we call that high pressure. And if there's a lot of low pressure or less pressure, less air, then we have low pressure. So I'm going to share the screen here. And actually, there we go. So here we have, on a weather map, you usually have H's for highs and L's for lows. That means that with this high pressure, there's a lot of air. There's a lot of air above it. There's a lot of density to the air. So that means the air will tend to sink. Whereas with low pressure, the density becomes less. Now, in order for clouds to form, we have to have the air going up. You need the air to rise. Without rising air, you can still get clouds if it doesn't rise, but in order to get some good clouds and to get a lot of rain and precipitation or snow, you need to get the air to go up. And the air goes up better when we have low pressure systems as opposed to the high pressure. So here's the high. It's got sinking air and it goes out. So the high pressure goes down. High pressure, the air goes down and then it spreads out. Low pressure, though, on the other hand, low pressure, as you can see, rises, it converges and rises. So with low pressure, you have air that's going in and going up, and that's how you get the clouds and precipitation. So what we have here with high pressure, you have what's called divergence. That means the air is diverging. It's going away from the high and spreading out. Low pressure air converges into a low and it goes up. So we have low pressure convergence, high pressure divergence. So what we get then, that's at the surface. So what we usually get above a low, the air at the low pressure converges at the surface, goes up, and then diverges when it gets to the higher levels of the atmosphere. The opposite is true for a high pressure. It diverges at the bottom, the air goes down, and the air at the top sinks and goes converges at the top and then sinks down. So this is what you get here, as you can see. Convergence at the surface of a low, air goes up, and that's how you get your clouds. And usually the high pressure is where you get, the lack of clouds usually in better weather. Now, if we had no spin, if the Earth didn't spin, what would happen is the air would come right out of a high, let's say high pressure, and it would go out like spokes on a bicycle. It would go out in all different directions. And with the low, it would be spokes going into the center of the low. But because we spin, we have what's called Coriolis. And that Coriolis allows the air, the Coriolis allows the air to spin. As opposed to going straight in, it kind of swirls in. And that's what Coriolis does. So with the high pressure, the air doesn't go straight out. The high pressure, the air curves out. And it curves into a low pressure. Now, usually on a weather map, we have what are called isobars. These are lines of equal pressure. So with high pressure, you would have the highest pressure isobars in the center of the high, and it would go lower as you go away from the center. With the low pressure, you would have the lowest pressure in the center, and the pressure would get higher as you go away from that low pressure. So oftentimes what we have here is we have, on a weather map, you have a high pressure like this, diverging out of the high and converging into the low in one more or less continuous motion. Pretty cool. So let's look at a weather map now and actually see this whole thing in motion. So here we have a weather map here, and we have H's for highs and L's for low. So if air is going down and sinking at the high pressure, would you expect a lot of clouds or few clouds? Well, you probably expect fewer clouds because, again, the air is sinking, clouds can't build up. And indeed, if you look at this high, I mean, you're not going to get no clouds, even, most highs, in fact, usually have some clouds. They just don't have a lot of clouds, typically. And that's what we have here. And notice, too, see how the circulation goes clockwise around that high. But you can see here, Carolina, Virginia, we have some clouds here, but not a lot. So let's spread it out, and let's go to this low pressure system. You can see with the low pressure, it goes in a counterclockwise circulation, okay? The high pressure went clockwise, because that's how a clock moves. And this is counterclockwise, going against clockwise, so to speak. So with this, we can see, remember, the green means rain. So we do have rain around this low. And we generally have, see all these gray splotches and lighter grays, even some whites? Those are all clouds. So we have constant clouds really from near Chicago all the way toward Rapid City. Where notice with the high, we just have this little batch of clouds here. And the low, we have the batch of a much bigger area of clouds. And we have some precipitation because the air is able to go up and cause the clouds and the precipitation. So that is your quick discussion today. So when you look at a weather map, whether it's school or at home, look at the H's, look at the L's on the weather map. Which ones have more precipitation? I think you'll find that oftentimes the L's, the low pressure, have the precipitation, which is rain or snow or sleet, and the high pressure normally does not. So there it is. That's your Weather Academy for this Wednesday. Take care of yourself, and we'll see you again next week.